So we'll take up the next problem of the development of lateral surfaces. The next problem is written on the board. I'll just read it. A rectangular prism. So you can see here it is the case of a prism. So prism means we need to use parallel line method to draw the development. A rectangular prism of base 40 mm by 25 mm and height 60 mm rests on HP on its base with the longer base side inclined at 30 degrees to VP. It is cut by a plane inclined at 40 degrees to HP perpendicular to VP, cuts the axis at its mid height. Draw the development of the remaining portion of the prism. So this is the problem given. So you are already familiar with writing the top view and the front view of the solid with the given condition. So you are familiar with the writing the front view and the top view of the solid with the given condition. So here the given condition is it is a rectangular prism 40 by 25, height 60, rests on HP on one of its base with longer base side inclined at 30 degrees to VP. So this is the condition to be satisfied while writing the top view and the front view. So while writing the top view, this is the 30-degree line. So with the help of 30-degree line, I have constructed the rectangular prism. So this is the top view of the rectangular prism. This is the top view of the rectangular prism. Top view. Now to write the front view, I need to get the projectors from each of the points. So from this point the projector is this, the second projector and the third projector and the fourth projector. So using the projectors from each point, I can draw the front view. So this is the front view. Now I need to name name all the points. I will start with this. This is A1. I'll take it as A1 because A is the top face and A1 is the bottom face. Therefore, I have put it in bracket A1. This is B, B1. This is C, C1, and this is D, D1. Okay. A, B, C, D is the top face of the prism. A1, B1, C1, D1 is the bottom face of the prism. Now if you try to draw this, here you will find A dash because it is the front view. This is B dash and this is C dash, this is D dash. Similarly, this is A1 dash, B1 dash, C1 dash and D1 dash. Okay. Now to identify the center, you need to join the diagonals for the rectangle. So join the diagonals. Use thin lines to draw the diagonal. It is just the construction line just to identify the center. Because if you draw with the thick lines, then that will termed as the pyramid. Entire problem goes wrong. So you need to draw these lines, the diagonal lines thin. Okay, just to identify the center. From the center, draw the axis. This is the axis. Okay. Now this is the front view of the said solid. I have not darkened this yet because I need to introduce the section plane, and whatever is the remaining portion after chopping off the solid with the section plane, whatever is the remaining portion, that remaining portion only I will going to darken. Okay. So what is the information about the section plane? The information about the section plane is it is cut by a plane inclined at 40 degrees to HP. Cut by a plane inclined at 40 degrees to HP and perpendicular to VP. Cuts the axis at its mid height. It will cut the axis at its mid height. So mid height, you need to identify the mid height. So first draw the height of the prism. Height of the prism is 60 mm. So mid height means 30 mm. Mark 30 mm. This is 30, which is the mid height. So introduce a section plane which is perpendicular to VP and inclined at 60 degrees to HP. You can just have a section plane something like this. It is a plane. Okay. Now, if I keep it like this is parallel to HP, perpendicular to VP. It is perpendicular to the board and parallel to the floor. Now, it is perpendicular to VP but plane inclined at 40 degrees to HP. So, if you just give the inclination 40 degrees to HP, this is the condition is given, which is 40 degrees to HP and perpendicular to VP. This is again perpendicular to the board. With respect to horizontal plane, this 40 degree. So, it has to pass by the midpoint of the axis. That is what given. So, from the midpoint of the axis, it has to chop off the solid something like this. So, it has to chop off something like this. Okay. Now, if you introduce a section plane here, which is 40 degrees, something like this. This is the section plane. So, the section line should be thick at the ends. So, this is the thick at end, this is thick at the end. Okay, section plane, you need to write it as a chain line, thick at the ends. That is what the fashion of writing the section plane. Each and every line in the case of drawing has got its own meaning. Okay, you need to use a chain line which is thick at the ends to represent a section plane. Now, this is the section plane which is cutting the front view of the prism, which is passing through the mid height of the axis 40 degrees to HP and perpendicular to VP. Now, this is the remaining portion which is kept on the floor. So, this is the remaining portion. I will going to darken the remaining portion now. This is the remaining portion, this is the remaining portion, and this is the remaining portion, the remaining portion, and the remaining portion. Only the remaining portion of the solid you just darken it. This is the remaining portion. So, you need to develop this particular portion, because draw the development of the remaining portion of the prism. That is what the question. So, this is the remaining portion of the prism. This is the remaining portion of the prism. This you need to develop. Okay. And since this comes under prism, we need to use parallel line method. That means to say we need to draw the development of this just beside the front view only. Okay. So, this is the front view. I am going to use the extended line of this. So, this is the extended line. I am going to extend this. Similarly, I am going to use the extended line, something like this. So, again this is the parallel line. These two are parallel. Okay. It is the parallel line method. Now, you can keep convenient distance between the front view and the development. Keep convenient distance and you just draw a line. Initially, draw lines with less amount of pressure, that is the thin line, because only the development part should be darker. Now, in the case of a cylinder, it was pi into d, the length. It was pi into d in the case of cylinder, which is circular. But here it is not circular, here it is having some edges. One edge of 25, another is 40, again 25, again 40. 25, 40, 25, 40. So, if you just cut open at point A, you will find 25 and then 40, 25 and 40. Okay. Therefore, you start with this, you draw line from this particular point of 25 mm, draw a vertical line. So, this represents this particular side. Next is 40. So, from this measure 40, draw a line vertical. Okay. Draw a line vertical. Similarly, after this again 25, so measure 25 from here to here, measure 25, draw a line. Then from here to here 40, again 40, so from this 40 you draw a line and you just chop off or erase the remaining portions. So this is 25 again and this is 40. Okay, this is where the development should come, the development of the said solid, which is just beside the front view of the solid. Okay, now we need to name the points where the section plane cuts each and every edges. Come back to the front view. In the front view, A-A1- is one of the edge, A-A1- is one of the lateral edge which is cut by a section plane at this particular point. So this point is called as 1 dash. 1 dash. So 1 dash is the point where the section plane cuts that particular lateral edge A-A1-. Similarly, B-B1-, the edge B-B1-, the edge B-B1- is cut by the section plane at this particular point. This I will call it as 2 dash. Similarly, the edge C-C1-, C-C1- is cut by the plane, section plane at this particular point. I will call it as 3 dash. And the lateral edge D-D1-, lateral edge D-D1- is cut by the section plane at this point. I will call this as 4 dash. I will call that as 4 dash. Okay, so 1 dash, 2 dash, 3 dash, 4 dash are the points where the section plane cuts the corresponding edges A-A1-, B-B1-, C-C1- and D-D1-. Now try to extend the line from A1- to the development, where again you need to name this. This is A, this is B, this is C, D, again it is A, because A should overlap with A once you fold it. Okay. So now A1 cut by the section plane at this particular point. From this point draw a parallel line up to A. This is 1 dash, and up to A. A is here also. This is again 1 dash. Just take a horizontal line from 1 dash. Okay. Similarly, from 2 dash, take a horizontal line from 2 dash. This is 2 dash, which is B1. Similarly, 3 C is cut at this particular point. This is 3, and the 4 is corresponding to the lateral edge D. So this is 4. Okay, we have marked all the points where the section plane cuts the corresponding lateral edges. Now just darken the remaining portion of the development. This is, and just join 1 dash, 2 dash, 2 dash, 3 dash, 3 dash, 4 dash, 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 4 dash to 1 dash, 1 dash to A, again A to, again A to A, A to A. Development is not completed yet because 2 dash to B is the retained portion of the edge BB-. Out of BB-, this is chopped off with the section plane. This is only the portion which is retained. Similarly, 3 dash C is the retained portion. Similarly, 4 dash D is the retained portion. So this is the development of the said drawing. Now you can draw this with the plane sheet, and you can cut this and stick it on any aluminum sheet, again cut it, and if you fold it, you will find this particular image. That is what the concept of development. Draw the development figure, you stick it on the aluminum sheet or any sheet metal, cut that particular sheet metal and try to fold it. You will get the desired shape. Okay, welcome back. So in this session we'll continue the problems on development of lateral surfaces. So in the previous session I have taken 2 problems, so we'll continue with the third one. The third problem is on a hexagonal prism of base side 20 mm and height 50 mm is resting on HP on its base such that one of its base edge is parallel to VP. The prism is cut in this position as shown in the following front view. Draw the development of the lateral surface of the prism. Okay. So here it is the hexagonal prism, and since it is prism, again we need to use the parallel line method. 20 mm side, so hexagonal prism of 20 mm side, so this should be 20 mm, the side of the hexagon 20 mm, and height 50 mm. The height of the prism is 50 mm. It is resting on one of its base such that one of its base edge is parallel to VP. So this condition is given to draw the top view and the front view. One of its base edge is parallel to VP. Look at here, the base edge is parallel. There are 2 base edges parallel to VP. Okay. So with this given condition, you are already familiar with writing the front view and the top view because you are already finished the study on the projection of solids. Okay. So this is what the top view and the front view, which is written in the exactly same manner as in the case of projection of solids. Now the prism is cut in this position as shown in the following front view. This is the front view. So here instead of giving the information about the section plane, so in the earlier session we have taken the problem on the section plane. The information about the section plane was 40 degrees to HP and perpendicular to VP. But now the front view is already given, so this is how the front view look like. Okay, it is already given with the problem only. We need to draw the development of the lateral surface of this particular portion. The front view, what is the front view given? This particular front view's development we need to draw it now. Okay. Now we'll understand the sides and all the corners. So hexagon has got 6 corners, so A, B, C, D, E. A, B, C, D, E, one more corner F. Okay. This is the top face. Again for the bottom face, A1, B1, C1, D1, E1, F1. You are already familiar with the naming also. It is exactly as good as the projection of solids. So similarly the front view, this is A dash, this is A1 dash, this is B dash, B1 dash, also B dash and F dash. B and F, there are 2 points which is overlapping. Therefore you will find F dash also here and F1 dash also, which is in bracket, which is not visible. Similarly C dash, C1 dash and E dash, which is in bracket, E1 dash, D dash, D1 dash. Okay. So this is the front and the top view of the said problem. Now looking at the front view, which is given along with the figure, along with the problem. Look at this. There are 2 section planes. We need to understand about the section plane. This is the section plane, this is one of the section plane, and this is one more section plane. So there are 2 section planes here instead of 1. Here the section planes are 2. So one section plane starts from the right corner, rightmost top corner, and it will end up with the left edge, which is 25 mm below the left top corner. Okay. One more cutting edge section plane starts with the leftmost bottom corner and end with the rightmost edge which is 25 mm either from top or from the bottom, which is at the center. Okay, because these two are in line. This is given as 25, therefore this should be also 25. Okay, so there are two section planes here, and since there are two section planes, you need to be careful. Now we need to name the points where the lateral edges cut by the section plane. So we'll take up the first section plane and we'll try to name it. The first section plane cuts the lateral edge AA1 at this particular point. This I will call it as 1 dash. The first section plane cuts the lateral edge B1 dash at this particular point. I will call it as 2 dash. The first cutting plane, section plane, cuts C1 dash at this point. I will call it as 3 dash. Again, the first section plane cuts this particular D1 dash at this point. This I will call it as 4 dash. Similarly, this first cutting plane cuts A, B, C, D, E1 dash at this point. Again, this is 5 dash, because and it is not visible because E is away from the observer. It is not visible. I will put it in bracket. So 3 dash is the point where the section plane cuts the lateral edge C1 dash. 5 dash is the point where the section plane cuts the lateral edge E1 dash. E dash, E1 dash. Similarly, 6 dash is the point where the section plane cuts the lateral edge F dash, F1 dash. 2 dash is again the same point. It appears same point, but it is not the same point if it is in the 3-dimensional view. 2 dash is the point where the section plane cuts the lateral edge B dash, B1 dash. Okay, that is 6 dash. Now move on to the next section plane. This is the second section plane. So next section plane, this second section plane cuts A dash at this particular point, A1 dash. I will call it as 7 dash. Then B dash, 8 dash. 8 dash is the point where the section plane cuts B dash, B1 dash at this particular point. Similarly, 9 dash is the point where the section plane, second section plane cuts the C dash, C1 dash. 10 dash is the point where the second section plane cuts D dash, D1 dash. 11 dash is the section plane point where the section plane cuts E dash, E1 dash, and it is not visible because it is away from the observer. Therefore, I have put it in bracket. Then 12 dash is the point where the section plane, second section plane cuts the lateral edge F dash and F1 dash. Okay, so there are 12 different points. 6 point where the first section plane cuts 6 lateral edges. 6 more points where the second section plane cuts the 6 different lateral edges. Okay. Now I need to start the development. Again, the parallel line method, we need to draw the development of the said drawing just beside this only. So we need to use the extended lines. So draw the extended line here. Draw the extended line from this, the bottom. So this is the parallel line. Now just keep convenient distance between the front view and the development. You can keep the convenient distance. You just draw a line which is the start point, that is A. Now what is the end point? End point depends on the number of sides. So number of sides in the top, you look at here, number of sides in the hexagonal prism. There are 6. 1, 2, 3, 4, 5, 6. AB, BC, CD, DE, EF, FA. There are 6 sides. And each side is equal 20, 20, 20, 20, 20, 20. It's a regular hexagon. Regular hexagon means all the sides are equal. So each side is equal 20, 20, 20, 20, 20, 20. Therefore, cut this with each side at 20, or divide this with each side 20, 20, 20, 20, 1, 2, 3, 20, 4, 5 and 6. 1, 2, 3, 4, 5, 6. Okay. So if 1 is 6, 20, from here to here, if you draw it, 6 into 20, 120. Okay, you need to write something like this. Now just erase the remaining portion because the figure should look beautiful. So erase the remaining portion. 1, 2, 3, 4, 5, 6. 6 division represents the 6 lateral surfaces of the hexagon. This is A, this is B, C, D, E, F and again A, because A should coincide with A at the end. Now start extending the lines from 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, similarly 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash. Start extending the line. This 1 dash is the point where the section plane cuts the edge A dash, A1 dash. So extend this with A dash, A1 dash. Similarly extend with A dash, A1 dash. This is 1 dash. This is 1 dash. That is the edge A. Capital letter A means A dash, A1 dash. Similarly 2 is for B, 2 dash, 3 dash is for C, 3 dash, 4 dash is for D, this is 4 dash, 5 dash is for E, so extend this for 5 dash, 6 dash is for F, so this is 6 dash, then 1 dash. So this is where the section plane, the first section plane cuts all the lateral edges. Now we'll move on to the second section plane. The second section plane starts with 7 dash. So 7 dash here, then 8 dash, 8 dash for B, 8 dash, 9 dash is for C, this is 9 dash, 10 dash is for D, this is 10 dash, or I will write it below. 11 dash is for E, this is 11 dash, 12 dash is for F, 12 dash. Again we need to join all the lines now. 1 dash to 7 dash is the retained portion, 2 dash to 1 dash to 2 dash, 2 dash to 3 dash, 3 dash to 4 dash, 4 dash to 5 dash, 5 dash to 6 dash, 6 dash to again 1 dash, 1 dash to A to F, F to E, E to D, D to C, C to B, B to A. The development is not over yet because we need to join 7, 8, 9, 10, 11, 12 and A. 7 dash to 8 dash, 8 dash to 9 dash, 9 dash to 10 dash, 10 dash to 11 dash, 11 dash to 12 dash, 12 dash to again 1 dash or A. Okay. Now again the development is not completed because 2 dash to 8 dash is the retained lateral edge. 2 dash to 8 dash, that you need to darken because this is the cutoff portion. This is the cutoff portion. Okay. This cutoff, this portion is going to cut off. Only the retained portion should be darker. 3 dash to 8, 9 dash is the retained portion. This will be cut off, this will be cut off. That is, this point will be cut off, this point will be cut off. Similarly, 4 dash, 10 dash is the retained portion. 5 dash, 11 dash is the retained portion. 6 dash, 12 dash is the retained portion. Oh, okay. Sorry. here I should not join this. I should not join this. So only this is the retained portion. One dash to A to 12, 12 to 11, 11 to 10, 10 to 9, 9 to 8, 8 to 7. Okay, so this is the development of the said front view of the said hexagonal prism. Okay, if you just cut this 7 dash to 8 dash to 9 dash, if you just cut this, and if you try to fold, all the edges, you will find this particular image, this particular desired shape. Okay, so this is the development of hexagonal prism.